Good morning, students. Today's topic is exploring force and frictional force. Before going to these topics, let me make you to understand what is the SI unit of force. Already I said in the first video, SI unit of force, we name it as a Newton. What is the meaning of SI unit? SI unit is an international system of units. You learn more about this when you go further, but to make you to understand at this level, I will give you an example like to measure a distance, we'll use a meter. To measure a time, we'll say seconds. Similarly, to measure a mass, we will use kg. Similarly, to measure a temperature, we'll use a Kelvin. All these are SI units of physical quantities. Similarly, to measure the force, the SI unit is Newton. Why it is Newton? So, normally in science, they will use scientists' names as in SI units because to recognize their work, they have did so many things to develop the science. So, in the same way, Sir Isaac Newton is also contributed so many things, so many content to the physics and mathematics. To honor him, we gave his name as a SI unit of force to recognize his work. Okay, so now let us move on to today's topic, that is exploring forces. First, I will take the forces applied on an object in the same direction add to another. Right? So this thing I did it already in the first video, but many of you asked doubts on this exploring force. That means the net force mainly. I will make you to understand what is the net force and how to calculate this net force today. Okay. So to understand more about this, let us go to the simulations. So in this, first I will take only the values now. Okay. I will send this person from the blue team. This is the tug of war. So there are two teams, blue team and red team. They are going to play the tug of war. Okay. Now I will take the blue team. Blue team, one person from the blue team, and he is going to apply 150 Newton and he is going to pull this car towards the left, right? And I will take one more person from the same team. Look at, and now this person is having 50 Newton, this is having 150 Newton. Total it became 200 Newton. Okay, let me check now what is the sum of forces. Sum of forces is nothing but your net force. Net force is meaning is the force applied on this cart. On this card, how much force is applied. So that is the meaning of net force. Okay, let me show you what is the net force now. The net force is 200 Newton. Why the net force is 200 Newton? Because only one side the cart is going to pull and it is going to move towards the left, and the total force acting on that cart is 200 Newton. Okay, so let us go back to the PPT. So we say that if in this team I only took the two persons from the blue team, the force applied on the object was 200 Newton because one person is going to apply 150, another person is going to apply 50 Newton. The total is 200. Why we are adding here? Because the two forces are acting on the same direction. Okay. Now let us see the next. What is the next case? If two forces act in the opposite direction on an object, the net force acting on it is the difference between the two forces. Now it's a different case. Now the red team is also going to participate. Let us conduct this game. I will send one person from the blue and another person from the red, and I will send one more person from the red, and I will send one more person from the red, from the blue. Okay, so these two persons are not going for playing. Okay, they want the rest and they are not going, and they went confidently this two person from the each team. Okay, now let us see their values. Look at the left side, the force applied on the cot is 150. Right side, it is 100. Right? Now, let us see who will win first. It is obvious that the blue team is going to win. Yes, let us clap for them. And we will come back to the written position. Okay. What is the net force acting on it? Now, let me not bring back the red team back, and I will go. It will go on. Look at this speed at which the cart is moving. It is moving very fast. Now, if I send them, now if I make them to play, it's going very slowly. Why it is going very slowly? Earlier it was having little more fast. Now it is going slowly. The reason is these persons are also pushing it towards it, and in this 150 Newton force, 100 Newton force is balanced and remaining is 50 Newton. So that is the meaning of net force. So we have to subtract now. The reason is both the side they are pulling in opposite direction, and the net force direction is towards the left because the left blue team are applying more force compared to the red team. Right? Now we have to subtract. Okay. Now let us go back to our PPTs. Here. Now let us take another case. Okay. In this case, when two forces acting on an object in opposite direction are equal, the two forces are acting in opposite directions are equal. The net force on the object is 0. Then the object won't move at all. So let us go back to the simulation. Now I will bring this one person from the red team and I will send this person. Look at now both the side the forces are equal 150 150. What should happen if I allow them to play? Nobody wins. The reason both the side is force acting is same. So left is pushing the card with 150 Newton, red is pushing the card with 150 Newton, and the force applied on the card is now 0 because with the same force they are pulling and they are pulling in opposite directions. So nobody wins to win, and the net force acting on this card is 0. That means sum of the forces acting on this card is 0. We have to subtract 150 Newton minus 150 Newton. Alright, I hope you understood this, the net force concept. The net force is nothing but the total force acting on that object. Okay, when to add? We have to add the two forces if they are acting on the object in the same direction. We have to add them. If they are acting in an opposite direction, we have to subtract. Even if they are acting in opposite direction and if those two forces are equal, then we have to subtract and the net force is 0 and the object won't move in that case. Okay, let us take this example here. So two persons are applying forces on two opposite sides of a moving cart. The cart still moves with the same speed in the same direction. What do you infer about the magnitudes and the direction of the forces applied? Magnitude means how much force. So amount of force, that is the meaning of magnitude. The direction also we have to show. Understand the question. Two persons are applying the force on two opposite direction of the cart. Okay, let us draw and show you the situation. Okay, let me draw and show you here the situation. I will take the card first. The card is like this. It is having the wheels. Okay. Now, the cart is already moving with some speed. Means let me say that it is moving with 20 meter per second. So again, meter per second is the SI unit of speed. We have come across this thing in 7th standard. Okay, 20 meter per second. It's moving towards the right. Okay, one person comes here in the left side, and he is going to push the car towards right with a force of, let me call, is going to push with an 8 Newton. Okay, another person comes in a right side and he is going to push the car with a force of again 8 Newton. Okay, what happens to the speed of that car? It moves with the same speed. Why? What is your observation? Look at the forces. So the question is, two persons are applying force on two opposite sides of the cart. The cart still moves with the same speed. What do you infer from then? If it is moving with the same speed, means the force of this person and force of this person should cancel, because both the persons are applying same force. Net force applied by the two persons are 0 because they are applying in opposite direction and the two forces are 0. So the cart is going to move with the same speed. It is not going to change, and it is not going to change even the direction. So direction is also in the same direction. So it is not going to change. The reason for this is the two persons are applying the same force and in opposite direction. So in that case, we have to subtract. So 8 minus 8 is 0. So the net force applied by them is 0. Right? So that is the way to understand this. Right? So let us clear. Today what we have seen is exploring forces, more about exploring forces, how to add, how to subtract. I revised the things. So already this I discussed in the first video, but still I took one more problem and made you to understand more about it. And today you solve those 5 questions which I have given here. Name the force exerted by all matter on all other matter. Name second question. Name the force which tends to slow down the objects or keep them from moving. The force with which a charged body attracts an uncharged body. A force cannot change the speed of an object, mass of an object, shape of an object, the direction of moving object. Explain the following types of force. So you have to explain each terms, each forces here: magnetic force, electrostatic force, gravitational force, and frictional force. And you should give one example to it. Don't take example from what I have given. So you have to take example from your own, your day-to-day life, and you have to write it here. Don't repeat the same examples. Take some more examples. Think more about it. Where did you observe these kind of forces? So why it is happening like this? So like that you have to cite your own examples. Okay, and stay home, be safe, and tomorrow I will discuss about the frictional force, more about frictional force. I'll take some more simulations on frictional forces and I will discuss. Okay, thank you. Have a nice day.